Right, I've used this black line to make up a makeshift salt trail on the ground. And it's basically darker in the centre and lighter on the outside. And I've just done it with a bit of spray paint on some paper. Now I don't have the sensors for my worm robot that'll eventually go on my worm robot. What I do is I have a couple of Lego sensors here pointing down that will read how light or dark the ground is underneath it. And this is basically, this little robot here is just going to simulate what the worm head would do without the rest of the tail. And it's got a very simple program. If that sensor is sensing more salt than the other sensor, then it does a muscle contraction to that side. If that one's sensing more than that one, then it does a muscle contraction to that side. So it'll just do a small little muscle contraction, wait 0.2 of a second, and then repeat the process over and over and over. And that's all the program does. Okay, now to see it in action, following that simple rule, whichever side has the most amount of salt under it, the worm head does a contraction on that side. And it causes the head to this wiggling worm-like behaviour. And what you'll find is when it's in a straight line, both sides have a very even amount of contractions. When we get a curve, you end up getting more contractions on one side than the other. And that makes it follow around. So that's what the head does, not the rest of the body, just the head. Just simply follows that rule. Whichever sensor has the highest amount of salt, you contract in that direction. And the result in that means, in a straight line, you have an even amount of contractions from side to side. On a curve, you end up with more contractions on one side than the other because it's quite common for there to be more salt under one side than the other. So it just simply works like that. Whichever one has the most amount of salt, we do a muscle contraction in that direction. When the line is in a straight line, you'll end up with an even amount of muscle contractions on both sides. When the line's curved, you'll end up with more muscle contractions on one side than the other because it's more common for the salt to be under a higher density under one side than the other because the salt trail is curving. Okay, since understanding how the worm works a little bit better, I've changed my program. The program I have now is I have a set movement for the heads. Either 5 contractions to one side, then 5 contractions to the other side, then repeat, 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 or more contractions on one side, then more contractions on the other side to simulate what the worm head was doing when it was following the salt trail. And what the rest of the body does is each section just does whatever the section before is doing, but only by about 85%. When I watched the videos, I found that the worm moves more of its head than its body, than down towards its tail. So what I've done is just each section just simply does what the section before does, but slightly less of it. And then the head, for the moment, has 3 programs that I can run. One program where it does the same amount of muscle contractions on both sides, another program where it does more muscle contractions on one side than the other, and another program where it does the other way around. So I should get 3 motions. The worm goes straight ahead, the worm moves to the right, and the worm moves to the left to be in line with that other program we run before. So just at the moment I have the head set up to do the same amount of muscle contractions on both sides, and then each body section just to follow what the head was doing before, but just to do fractionally less of it. When I get that sort of motion, which is actually quite an efficient bit I've got. You can see how quick the worm goes forward, and very close to the real video when you watch the real worm. Okay, here I have my worm robot, and all I've done now is I've changed that the head, instead of contracting an even amount on both sides, it's going to contract on one side more than the other, and the rest of the sections are just going to do exactly what they did before. They just simply get the value that's in front of them and follow it through, just do fractionally less. So that way it's very much imitating what the last robot was doing when it was following the salt trail. When I do that, you can see it's because it's got more on one side than the other, it causes the robot to turn. The robot turns around in a circle. So you can see the wiggling bit the head was creating when it had the same amount of contractions on both sides. It caused the worm to go straight ahead. When it has more contractions on one side than the other, it causes the worm to go around the corner like that.